Hello, welcome back to my class. So last time we talked about domain and the range. This class we're going to talk about what's the domain and the range of the toolkit functions. So for identity function, domain again is the possible value of all the input value. So input would be x, all the possible ones. So in this case, the graph can go to the left and right as far as they want. So the domain of this toolkit function is going to be negative infinity to infinity, whereas the range, since this is a constant function, so the range is always equals to some constant. In our specific example, this is equals to 4. So for identity function, if you take a look, the function for the domain, as you extend in the function to the right or to the left, it can go as far as they want. So this is going to be negative infinity to infinity, and the range also be negative infinity to infinity. For absolute value function, domain, again, when it comes to domain, you look at x. X means the horizontal direction. You can go right, you can also go left. So this is going to be negative infinity to positive infinity. For range, you can go down because you think about absolute value function. Can you be a negative? If you put in the next number, what happened? After you take the absolute value, it's going to be positive. So that means the range is from 0, because they can be equal to 0, the output, to positive infinity. So you can only go up from 0 to go up, but it can be something below 0. Okay, next one, quadratic function, similar to the absolute value function. Domain is going to be negative infinity to infinity. Range is going to be 0, including 0. That's why I have a bracket. And then go up, which is positive infinity. Cubic function, which is x equals to x to the cube. Domain is going to be negative infinity to infinity. Range, they can go up and down as far as they want. So it's going to be negative infinity to infinity. Now try this by yourself. If you look at the graph, what will be the domain? All the possible value of x. So x can be what? Go to both ends, which is negative infinity to infinity. But x cannot be what? In the reciprocal function. X cannot be 0, so that's why we can't include in 0. Union means these two sets together. So that means from negative infinity to infinity except for 0. Range is similar, negative infinity to infinity, but not including 0. Reciprocal squared function. Well, for the domain, when you look at this graph, tell me, what would that be? Negative infinity to infinity, right? Union 0 to positive infinity. And range is what? You need to look at the vertical. So vertically, they can only go up, right? They can also go down, but the furthest they can go is to 0, not including 0. They can go something below, because when you square everything, it's going to give you a positive number. So that means it's from 0 to positive infinity. You can tell by this graph. Remember that the domain is you look at vertically, range is, domain is you look at horizontal direction, range is look at vertical direction. So for the square root one, for the domain is what you start in from the origin, which is 0, and goes to the right. So that means it's positive infinity. For range, the same, 0 to positive infinity. Cubic function, which is negative infinity to infinity. They can be negative. And for the range, again, negative infinity to infinity. Okay, that's it for all those toolkit functions. So now let's find the domain of each function. Let's have some examples. Find the domain of each functions. Now I have fx equals to square root of 2 times square root of x plus 4. The second function is going to be g of x equals to 6 minus 3x. 3 over 6 minus 3x. Okay, so since we can't take the square root of a negative number, we need the inside of the square root to be non-negative. Remember here, for the most basic toolkit function of the square root function, everything inside the domain has to be positive, right? So that means everything inside that domain, inside that square root, has to be positive or equals to 0. So that means I want x plus 4 greater than or equals to 0, because you can't have a negative number for the square root. So that means x is greater than or equals to negative 4. In that case, the domain of the function is starting from negative 4 to infinity, because it's greater than. Okay, the other one is here a reciprocal function. It transfer from a reciprocal function. So we cannot divide by 0. So we need the denominator to be non-zero, right? So we have 6 minus 3x. They can't be 0. So when we solve that, we can treat it as a equation. So I have subtract 6 on both sides. I have negative 3x not equals to negative 6 divided by 3, negative 3. So I have x equals to 2. Not equals to, I'm sorry. Not equals to, but you treat it like equation, but we just use in equal sign. So that means what? X can be anything except for 2. All right, so the domain of the gx function is negative infinity to 2, not including 2. So that's why it's parentheses, union 2 to positive infinity. Okay. So what if I combine a square root function and the reciprocal function together? So here is another example to find the domain. h of s equals to, let's say, 5x plus 2 square root over 2x minus 1. Let's say this. So now when we take a look, we can separate into two parts. They need to both satisfy these conditions. So first of all, we know that under the square root, everything has to be non-negative. Remember, it's non-negative. That means including 0 and positive. So that means on the top, inside the square root, I have 5x plus 2 greater than or equals to 0. So when I solve for x, I have x greater than or equals to negative 2 over 5. For the bottom, I have 2x minus 1 not equals to 0, because everything under the denominator, it can be 0. So I have x is not equals to 1/2. Okay, So now we need the function satisfy both condition. Then we will find the domain, right? Remember, they have to satisfy these two conditions. So now let's draw number 9 and see what does it look like. So if this is 0, this is infinity, and this is negative infinity. So x has to be greater than, let's say this is negative 2/5, and this is 1/2. All right, so for the first one, I am going to use a green highlighted. See what does the function look like. So x has to be equals to and greater than negative 2/5. So that means everything to the right, from negative 2/5 to the right. And then the other one is, I'm going to use a gray one, x not equals to 1/2. So that means x can equal to everything but 1/2. So x a circle, because you can equal to 1/2, and then but everything else it works. So now let's look at this highlighted part. So the gray one is represent x not equal to 1/2. The green one is represent x is greater than or equal to negative 2/5. So now let's look at which part they overlap. So the overlap part means they both satisfy these two conditions. So the overlap part should be from including negative 2/5 to 1/2, because these part they're overlapping, right? Including the 2/5, and then to 1/2 to infinity, right? So this is the domain of h(x) function. Is this one, including negative 2/5, but not including 1/2, because x cannot equal to 1/2. So here is the domain for the toolkit function. All right, next time we will talk about piecewise function.